Okay, so today we are going to just recap the key things that are going to be on the test that covers lessons 5, 1, 2, and 3. So on this one, let's see, the first part is converting from degrees to radians. So the thing you got to remember is that when you want to convert, you have to make sure the one that you need to cancel is on the bottom. So like if it's going from degrees to radians, I need the degrees, the 180 degrees, to be on the bottom, so that this degree, the unit, will cancel. And then at this point, you can use your calculator. Now remember, if you're using your calculator, you're going to do 330 over 180 and get a fraction, okay? So that's 11/6. And then when you write your answer, this would be 11 pi over 6. So just make sure you know how to do that, because I'm going to want an exact answer. I'm not going to want a decimal on that one. Now, when you go from radians to degrees, it's basically the same thing, only now we need the radians to cancel. So when we do times 180 over pi, so basically the pi and the radians units will cancel here. So when you put that in your calculator, you're basically doing 7 times 180 on the top, 3 on the bottom, but of course I don't think it matters in this one because you don't have to worry about it. It's coming out to a nice pretty whole number answer, and you get 420. And it is degrees, so put the degree symbol. Okay, so you need to be able to go from one way, to both of those. The next thing you need to be able to do is find coterminal angles. Now, notice it says one positive and one negative. So you're going to have a positive answer, you're going to have a negative answer for each one of these. So if it's in degrees, I want the answer in degrees. If it's in radians, I want the answer in radians. So for degrees, to find a positive and negative coterminal angle, all you really have to do is add 360 and subtract 360. Okay, so if you add 360 and you subtract 360, you should get your two answers that are correct. And if we add 360 to 265, we get 625. So this is the positive coterminal angle. And then if we take 265, subtract 360, we get a negative 95, and that is our negative coterminal angle. So you need one of each. When we're dealing it in radians, then we add and subtract 2 pi, because remember 2 pi is the same thing as 360. So I'm going to add and I'm going to subtract 2 pi. Now when I'm plugging this in the calculator, I'm not actually plugging in pi. So I'm going to go in a different color over here. When I plug this in the calculator, I'm doing 7/6 plus 2 and getting this as a fraction. This is 19/6. Okay, so then on my answer, I know this is 19 pi over 6. Then subtracting, it's the same thing, but we subtract instead, so we get negative 5 pi over 6. Pretty straightforward. Now this next part, you're going from decimal degree to the DMS form, and you certainly can use your calculator. That's kind of how I showed you to do it in class. So this is very much a calculator problem, both of these. All you gotta do is know how to plug it in. So on this one, you would type 340.375. Do not put the degree symbol in, okay? And then the key you would hit, you know what, let me look at that right quick and make sure I'm telling you the same thing. It's second apps. So the key would be second, the second button, and then apps. And then you tab down to the fourth one where it has a little thing that says DMS, okay? And then you hit enter there, or equals, or whatever after you get it in there. And you should have 340 degrees, 22 minutes, and 30 seconds. Okay, so what I need you to do is make sure that you're putting this in correctly. And one thing I want to point out, you see how this is 340 is in front of the decimal? that is this piece right here. So if you accidentally plug in your degree symbol in your calculator, it's going to give you something different. So if you don't have that same piece right there, that should be a red flag that something is wrong. All right, so now we're going to go the other direction. So it's very similar. It's just calculator use. Problem is these things are kind of not in the same place, which I'm not sure why it just isn't. Okay, so on this one we would put, oops, I'm on highlighter. Okay, 253, and you have to hit the degree symbol. So to do that, you would do the second and the apps button, just like right up there. And the very first one has the degree symbol. Okay, so that's where you get to it. Then you would type in the 46, and you go to the second apps again. And this time the second one has that little tick mark. You got to tab down till you get there. And then you put in the 5, and notice that other one wasn't there. So to get to that, it's a little bit different. You have to hit alpha and then the plus sign, okay? That little double tick mark thing is hidden right there. And then once you get it done, just hit enter, and it's going to give you 253.7681. We're going to go to 4 here. It's going to tell you on the test where to round to on all of these. So just read the directions, make sure you round to the place that you need to. All right, so in 5.2, we looked at the area of a sector, and you're going to need to memorize these formulas, okay? So to find the, we also looked at arc length. Okay, to find the arc length, S equal R theta. Okay, so S is your arc length, and theta must be in radians. So that's your arc length. And then the theta right there must be in radians. So if it's not in radians, we have to fix it. So just be careful with that. That was the key. You have to put theta in radians for this to work. All right, so let's see. The first one, find the arc length when theta is pi over 4 and the radius is 14.5. So S is equal to the radius, 14.5. Arc length is pi over 4. The nice thing about this is it's already in radians, because that is radians. So at this point, I just can plug all of this, pi and everything, in my calculator, round it off. Okay, this is about 11.4 inches. Now on the test, it's going to tell you where to round to. Okay, so just, pay attention, whether it's 1, 2, 3, whatever. Okay, here I'm just going to do 1, because that's what we had did in our notes in the class. Now notice on this next example, it's the same thing, only this time theta is in degrees. So I need to go to the side and fix that. So let's see, this would be 120 degrees. I gotta change it to radians. So this ends up being 2 pi over 3. Make sure you can do that. Okay, that's something we did on that first page. So now I can use my formula. S equal R theta. R is 1.8. Theta is 2 pi over 3. At this point, I'm just going to plug everything in my calculator and round it off. That means that, including pi, okay? Anytime I'm rounding things off, I will plug everything in that's there. Alrighty. And you use the same units. Notice I did the same units as the radius on the other one. This one, I'm doing the same units as our radius here. So use the same units. Now, the next formula you have to know is the area formula for a sector. It's 1/2 r squared theta. Now, you can write it as area is 1/2 theta r squared. It doesn't matter, okay? These are the same thing. It doesn't really matter which order you put it in. Then when we go to find the area, again, it's the same thing where theta must be in radians. So that must be radians to use it. So notice, again, they gave us something that said 74 here. So I've got to change this to radians to be able to use it in this formula. And if you figure out what that becomes, this is 37 pi over 90. You want to make sure you do all that. and can get the correct answer at each step. Don't just assume because you watched me do it, you can do it, okay? All right, so now we need to find the area of the sector. So area is 1/2, and the radius is 4, and theta is 37 pi over 90. Now I can plug all of that in the calculator, and you get 10.3. And because the radius is centimeters, we're using centimeters, and because it's squared, the units are also squared. So this area is 10.3 units squared. And yes, I did round that off. Again, on the test, it's going to tell you where to round to, so read the directions, please, and make sure you're rounding to the correct spot, because I'll take off if you don't round to the correct spot. All right, now this one says use both of these formulas in context. You may see some word problems, that ask you to do something with one of these, but we did these in class, we did these in our homework, so it shouldn't be much of a surprise. So here's one that gives, or they ask us to find the radius. They give us the area of this sector, and they give us the central angle. So let's plug in what we know. We know we're using that area formula that we just wrote down. We do know that this 240 has to change, right? 240 degrees. If I need this theta, I need it to be in radians. So they're messing us up again, making us do a little bit more extra work. So 4 pi over 3. All right, now I got the radians. So now I can plug in the formula. Area is 1/2 r squared theta. Let's see, area is 134. R is what we're looking for, and theta is 4 pi over 3. Now, we need to isolate the R. So first thing I'm going to do is multiply by 2. So that's 268. And now, you know what? I'm going to write this down. I'm going to multiply by 4 pi over 3. No, 3 over 4 pi. Got to say it correctly. I mean, I wrote it correctly, just didn't say it correctly. I'm going to multiply by the reciprocal of that fraction. So when you do this, make sure you put it in your calculator correctly, because it's very finicky about that, on how you put it in. You may need to stack that fraction and make sure the 4 pi is on the bottom, or use your parentheses to make sure it comes out right. And this doesn't come out to be a perfect whole number, but we're going to round this off because this is about 64. And then we take the square root, so we're going to say it's about 8. And this is feet, because the area is in square feet, so I know the radius must be in feet. So just make sure you can, do all the steps correctly on that. Alrighty, so then the next one looks at distance. Okay, this is distance of two cities on the Earth, and the Earth is round, it's not flat. It's... Okay, I'll just leave it like that. It's not letting me do a box. Driving me crazy. Sometimes it does, and oh, there we go. Okay, good. All right, so here we want to know how far apart the two cities. So we're using S equal R theta, because this is the arc length. So if you can think of this Earth as a circle here, and we're looking, this is the center of the Earth, and then there's two cities directly north of each other. So that means we're wanting to find out this length. Okay, it is arc. So this is our radius, and we need the angle here in between the two. So I know it looks kind of interesting, but we can do this, guys. All right, so let's see. We want S. R, the radius is 3,960. Theta is the difference between the two cities, but they gave it to us in degrees. So we need to... One city is here, the other city is there, subtract it, what is that, 5.4 degrees? Okay, so the distance of the angle is 5.4 degrees, but we need to change this to radians. So there we go. The issue is, though, when you plug this in your calculator, a lot of times it doesn't want to give you a fraction. So let me plug it in myself right now. You can do it yourself too and see what comes up here. Okay, mine just gave me a decimal. It's not giving me a fraction. So you can use that so this is approximately, I'm going to write it all here, 0.0942477796. I suggest don't round it off, okay? Use that. Or just leave it in your calculator when you do that piece, because now we can just say whatever that is times the 3,960. Oops, that's a 9.6. Same difference. Okay, so if you just leave it in, just go times 3,960, boom, and then we're going to round it off here. So you don't have to worry about getting a fraction in the right form and all that. So this is miles apart because the radius is miles. So they're like 373.2 miles apart. So just, if you're using your calculator, it makes it a little bit easier. All right, let's look at the last section, linear and angular speed. Okay, so this hopefully isn't too traumatic for you, but on these, you just have to know the linear speed formula and the angular speed formula. So you're gonna have to memorize them, okay? So V is like velocity, which is linear speed, and it's R theta over time. And again, theta needs to be in radians, just like before. So that must be in radians. That's not changing, okay? So I'm gonna put that is like velocity. You can think velocity, which is your linear speed. Okay, the other one for angular speed is like a fancy little W here. Okay, that's theta over chi. So notice it's the same exact formula, except it doesn't have the radius in it. The radius makes it be the linear part because that gives us the length. Okay, so the angular speed doesn't have that. Okay, so this would be your angular speed. How fast is the angle itself moving? There's no length of measurement in there. So you're going to have to know those formulas for the test because I'm not giving it to you. Okay, so on the first part, find the linear speed of a CD. Diameter is 120. So I know I'm going to need the radius. So the radius is half of that. So the radius is 60. It rotates at 45 revolutions per minute. So it's going around the circle 45 times in a minute. So when I go to write my formula to find the linear speed, my radius is 60. And as far as theta, well, that's 45 trips around the circle, and every circle is 2 pi. And that's the radian equivalent of the circle, right? We're not going to put 360 degrees here. We're going to put 2 pi because we need it to be in radians. So 45 trips around the circle, and each circle is 2 pi. And per minute would mean 1 minute. So at this point, we can plug all this loveliness in your calculator, and I want you to do that. Make sure you're getting the right thing. And we are going to round off to 1 after, and again on the test, it will tell you where to round to. 16964.6, and this is millimeters, because that's what the radius is in, per minute. So yes, you need to put your units. So make sure you're knowing how to get this and get the correct answer. All right, so we're going to use the same exact problem, but this time we're finding the angular speed. So on the angular speed, we're using basically the same equation, except we don't need the 60. So notice how it's in the problem, but this diameter of 120 millimeters, we don't need that to find angular speed. We don't need the radius because the radius is not in the formula. So it'll be there to try to trick you to see if you're going to recognize when to plug it in and when not to, but don't fall for that, okay? So this is the same thing, basically, the same part of the formulas we just wrote, but notice the only thing different is it doesn't have the 60 in it. It doesn't have the 60 millimeters. So this is just, it went 45 revolutions around the circle in a minute. So that is our angular speed. So when we plug all this loveliness in, we get 282.7, and angular speed is always radians per whatever time unit that they give you in the problem. So angular speed will never have a linear thing to it. That's only the linear speed ones. All right, so now the last one. Yay, almost done. Okay, so this is, you got to be able to use them in context with word problems, and that's what makes it hard. I suggest go back through your notes and work out any problem that you're just not sure about in there, or you know, just to practice. Work them again. This one says Ryan is riding a bicycle. Wheels are 28 inches in diameter. Again, diameter, they're trying to trick us here. So that means we know the radius is 14 inches. If the wheels rotate 130 RPMs, that's revolutions per minute, find the linear speed in miles per hour, so we're going to have to convert here, in which he was traveling. Okay, so this is inches, and he's going, let's see, theta would be the 130 revolutions per minute. So 130 trips around the circle, every circle is 2 pi in 1 minute. Okay, so the linear speed, that's your V, is 14, that's your R. Theta is 130 times 2 pi, and time is 1 minute, because that's how far he's going. All right, so this would give us, I'm gonna just leave it exact right now. I'm not gonna round it off because I don't want round off errors. So if I plug this in, I'm gonna say 14 times 130 times 2, and I get 3640, and I'm gonna leave my pi right here. And this is inches because the radius is in inches over 1 minute. And the reason I'm leaving it like that is because we want our final answer to be in miles per hour. So if you want it in miles per hour, you want the final answer to be as accurate as possible. So you don't want to round off too early. So we're going to take this answer that we had in inches per minute, and we're going to convert. All right, so first thing I'm going to do is change inches to miles. So I know there's 12 inches in 1 foot. And the reason I put the inches on the bottom, because now inches and inches will cancel out, which is what I need it to do, because I need to get to miles. Now I have to go from feet to miles, and I know there's 5,280 feet in 1 mile, and you need to know that too. So if you don't know that, memorize that fact, okay? So feet and feet now cancel. So now my length units, or my linear units, are miles, and that's what it needs to be. So now I'm going to go to the time. We need it to be in hours, and I have minutes. So let's see, the relationship between an hour and a minute is there are 60 minutes in 1 hour. So I'm putting minutes there so my minutes could cancel, the units could cancel. So this is where that comes in handy. So at this point, I'm going to go multiply all this on the top. So the 3640 times 60, that gives me 218,400, and of course still got my pi. This is miles. On the bottom, if I multiply across, 12 times 5,280 gives me 63360, and this is hours. Now I can plug it all in. Top, divided by the bottom, including the pi, because now we're going to a decimal. Now we're rounding. So this is 10.8 miles per hour about, okay? And always check to see which place you need to round to. On the test, it should say. All right, we've finished our little review. If you have questions for me, please sure to stop by and let me know.